Welcome to this hands-on walkthrough of HTML injection labs from Hacktify Cybersecurity. HTML injection might seem like an outdated issue, but it remains a serious threat in modern web applications. In this tutorial, I'll guide you through the key concepts, real-world examples, and a step-by-step breakdown of the labs to understand how this vulnerability works and how to mitigate it. HTML injection occurs when a web application fails to properly handle user input, allowing attackers to inject malicious HTML content. Unlike SQL injection, which targets databases, HTML injection manipulates how a web page renders. This can be used to deface websites, create phishing attacks, or even enable further exploits like cross-site scripting. There are two primary types of HTML injection. Reflected HTML injection happens when user input is immediately displayed on a page without being stored. Stored HTML injection is more dangerous because malicious content gets saved in the database and appears whenever the page is loaded. This vulnerability has been exploited in major incidents. In 2025, an HTML injection flaw in PHP-MyFAQ allowed attackers to break the site's UI, rendering it unusable. In 2024, over 7 million WooCommerce websites were affected by an HTML injection vulnerability that allowed attackers to manipulate order notes, potentially leading to phishing attacks. Now, let's dive into the Hacktify HTML injection labs and explore real-world scenarios where these vulnerabilities exist. In the first lab, an insecure search field allowed user input to be rendered as HTML, leading to content manipulation. The second lab demonstrated how user profile fields could store and display injected HTML, allowing attackers to alter user profiles or insert phishing forms. In another scenario, file names were vulnerable. If a web application doesn't sanitize uploaded file names, an attacker can insert HTML or JavaScript into the file name itself, potentially leading to stored cross-site scripting. The labs also covered how HTML injection can be performed through URL parameters. When an application fails to sanitize user-supplied data in the URL, an attacker can manipulate page content just by altering the URL. Encoding techniques were also tested. Encoding malicious payloads can bypass basic security filters, allowing attackers to execute scripts despite security measures. Securing a web application against HTML injection requires several best practices. Always escape output properly to prevent raw HTML from rendering on a page. Implement a content security policy to restrict unauthorized scripts. Validate and sanitize user input before storing or displaying it. Secure file uploads by restricting file types, renaming files, and storing them outside publicly accessible directories. Keeping applications and plugins updated is essential, as new security patches help mitigate vulnerabilities. Security is not just about tools, it's about awareness. Training developers on secure coding practices ensures that these vulnerabilities are caught before they become exploits. A detailed write-up, including all the code and examples used in this video, is available in the description via Medium and GitHub. In the next tutorial, we'll be covering cross-site scripting and how attackers exploit web applications using malicious JavaScript. If you've encountered HTML injection vulnerabilities before, let me know in the comments. How did you handle them? Thanks for watching, and see you in the next one.